Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher. Today we are going to discuss the next topic from the chapter acid, bases and salts. The title of this topic is what do acids and bases have in common. That is nothing but we are going to discuss the further reactions of acids and bases one by one. In the last class, let's have a quick recap of last class first of all. In the last class we have discussed first of all introductory part about acids and bases. Then we have seen some reactions of acids and bases in the last class. So this is a recap for reaction. So first reaction we have discussed is reaction with metals. Reactions of acids and bases. Reaction with metals. Metals react with the acids or bases, give metal salt, and then we have seen the reactions of reaction in between metal carbonates and bicarbonates with acids. These are the second reaction which we had discussed in the previous class. So now in today's class we are going to discuss the next reaction, the third reaction, and that is that is the reaction between metals and reaction between atoms, acids and bases. Reaction between acids and bases with each other. Okay, we see with each other, acids and bases with each other. So that is the next reaction which we are going to discuss in today's class, right? So that is very easy reaction, guys. So one simple formula you can remember: acid will react with base, will get salt and water. So that is the simple thing. Acid will react with the base, will give salt and water, right? So here this reaction is going to neutralize the effect of acid and base, right? Okay, therefore this is also called as simply neutralization or acid base neutralization reaction. Neutralization means what? Decreasing the effect. Neutralization reaction. Okay, acid base neutralization reaction. Acid will react with the base and will give you the salt. Salt is neutral and therefore this is neutralization reaction. Let us see some examples over here. So simplest example, I'll write down few examples here and tell you how to write down the products. First of all, let us see HCl aqueous plus NaOH. Okay, then aqueous, then it will give you salt, right? So how to write down the salt? Very easily. First of all, remove water from it. After loss of water, let us see what is remaining. So water will be removed like this, H2O, right? H2 and O. Then what is remaining? Remaining is Cl and Na, right? Remaining is Cl and Na. So in this Cl and Na, we know that Na is the positive and Cl is the negative part. Therefore we'll write down Na first and then write down Cl first, right? As we know, the charges on Na and Cl, this is +1 and -1. +1 for Na, -1 for Cl. So we can very easily form their compound by multiplying it by 1 only, right? No, because already the charges are cancelled out. Their formula is NaCl, right? NaCl will be produced here. The name of NaCl is, which is a salt, the name of NaCl is sodium chloride. So salt produced in this reaction is sodium chloride, right? And then the names of the acids and base also I will write down. Yes, so name of the acid is hydrochloric acid or hydrogen chloride, hydrochloric acid, and the base is sodium hydroxide. The salt which is produced here, it is water soluble, therefore I will put AQ here. AQ stands for aqueous solution, and for water I will write down L. So this is the first example for acid base neutralization. Okay, next example we can have, I'll keep the acid constant. Okay, HCl aqueous I'll keep as it is, I'll just change the base. Now remember, whatever reaction you observe for NaOH, exactly same reaction you will observe for KOH. KOH is nothing but potassium hydroxide. Okay, KOH is the formula for potassium hydroxide. Whatever reaction you observe for the Na, same reactions are obtained for K also, KOH also. So we will get KCl plus H2O, right? Yes, so same reaction, just replace Na by K. So this is potassium chloride. Potassium chloride. Okay, yes, so then again I'll write down another example. Here I'll keep HCl again constant. Just observe how I'm writing the reactions, okay? And I'll change the base to MgOH twice. Okay, HCl is hydrochloric acid, MgOH twice is nothing but magnesium hydroxide, okay, which is present in milk of magnesia, which is used as an antacid, magnesium hydroxide. Okay, yes, so here also let us see how to write down the product. First of all, remove water. Okay, after removing water, what is left? Mg and Cl, right? As you can see, Mg and Cl is left. So in between Mg and Cl, how the product is formed, let us see. So we know that Mg has 2 plus charge because it is an alkaline earth metal. Na and K are alkali metals. Okay, I will write down it here. What we have seen the examples of Na and K. Na and K are alkali metals. Okay, alkali metals, they belong to group number 1 elements. Okay, and they have alkali metals. All the alkali metals have plus 1 charge. Okay, yes, all the alkali metals have plus 1 charge. Okay, now Mg is not an alkali metal, but Mg is alkaline earth metal. Okay, that also I will write down here. Yes, magnesium, Mg is magnesium, is alkaline earth metal. Magnesium is alkaline earth metal. Okay, that is, it belongs to group 2 of the periodic table. So it is group 2 elements, and they have alkaline earth metals have plus 2 charge on them. Alkaline earth metals have plus 2 charge on them, right? Therefore, let us see how to form the molecule by using Mg, which has plus 2 charge, and Cl, which has minus 1 charge, right? So you can see, to neutralize the charges, molecule as a whole should be electrical neutral. You are going to multiply this by 1 and this by 2, right? Therefore, what will be the formula? Mg multiplied by 1, Cl multiplied by 2. MgCl2 will be the formula, right? Okay, that I'll write down here now. What is the salt produced? MgCl2 aqueous. Okay, MgCl2, name of this salt is magnesium chloride. Okay, what is the name of this salt? Magnesium chloride, right? So this is how we can write down the acid base neutralization reaction, whatever may be the salt given. Okay, you can just take a screenshot of this page, and then we'll see next examples. Okay. Okay, yes. Now let us see some other examples now. Now I will change the acid to H2SO4. Okay, H2SO4 aqueous, then NaOH is the base, aqueous, giving you salt plus water. Okay, so H2SO4 is nothing but sulfuric acid. Okay, now here after removing the water, hydrogen and oxygen, we are left with Na and SO4, right? Okay, so with Na and SO4, how to write down the product? Let us see. So Na has +1 charge, SO4 sulfate ion has 2 minus charge. Okay, SO4 2 minus is called as the sulfate ion. Okay, it has 2 minus charge. How to write down the product? So to neutralize the charges, multiply Na by 2, SO4 by 1. Therefore the formula will be Na2SO4, right? So let me write it down here. So we'll get Na2SO4 aqueous, right? Na2SO4, the name of this salt is sodium sulfate. Sodium sulfate, right? Okay, now again I'll keep the this acid constant, and I'll change the base. Plus MgOH2S I'll write down. So here what we are getting, Mg as well as sulfate, both of them has +2 charge. Therefore it will be MgSO4 only. What will be the name of this compound? It will be magnesium sulfate. Okay, yes, so this is how we can write down the reactions with sulfuric acid. Now again you can take a screenshot of this page. Okay, so this is how these are the reactions in between acids and bases. Okay, these reactions are called as the neutralization reactions. Okay, after this we are going to discuss the next reactions of acids and bases. Fourth reaction. Yes, fourth reaction we are going to discuss reaction of metallic oxides with acids. Okay, now here why we are going to perform the reaction of metallic oxide with acid, because as we know metal oxides or metallic oxides are basic in nature. They are usually basic in nature. There are some exceptions, but we are not going to use those exceptional examples here. So this is the reaction of metallic oxide with the acids, right? Okay, let us see how this reaction is. So for that purpose, yes, so first of all I'll take the simple example, or I'll write down the general reaction first. So when we take the metallic oxide, just give me a second. Okay, so here when we take metallic oxide, so metallic oxide is nothing but basic in nature. So when we are taking that metallic oxide, it will act as a base, and just like when we treat base with acid, we get a salt and water, as base plus acid plus base gives you salt and water, right? Exactly same reaction will take place here. When we treat the acids with the metallic oxide, we get the salt and water, right? Okay, so let me write it down. So we are going to use the metal oxide will combine with acid and we'll get a salt and water, right? Some examples we can have one by one. Okay, so first of all, example of one metal oxide, ZnO, solid, plus acid HCl I'll take, aqueous, it will give you water. I will remove. Let us see what is left. So this ZnO is nothing but zinc oxide. Zinc is a metal, ZnO is the zinc oxide, right? So after loss of water, what is left? Oxygen from here, hydrogen from here. After loss of water, what is left? These things are left, that is the zinc is left and Cl is left. Zinc is having the +2 charge, Cl is having -1 charge, right? So how they can form the compound? Molecule as a whole should be electrically neutral. Zn will be multiplied by 1 and Cl by 2. So the formula will be ZnCl2, right? So what we are getting here? We are getting ZnCl2, right? ZnCl2 solid. Okay, name of this ZnCl2 is zinc chloride, right? We are getting zinc chloride. Okay, yes, this was the first example. Next example we can write down. It was between Na2O and HCl. Na2 solid, HCl aqueous gives you, first of all remove water from this, and the formula for NaCl, sodium chloride, is this. So this is the salt obtained. Sodium chloride, which is a salt, and the oxide which is used here is the sodium oxide, right? Yes, so for balancing I'll put 2 here and 2 here, that's it. So this is the reaction of metal oxides with acids, right? Yeah, just take a screenshot of this page. Reaction of metallic oxides with acids. Okay, yes, I hope you have taken a screenshot. Now let us see the next type of reaction. Reaction of non-metallic oxides with bases, right? Okay, just like I have told you, metal oxides are basic in nature, usually they are basic in nature, while non-metallic oxides are acidic in nature, right? Therefore fifth reaction is with the base only, right? Metal oxides will not react with the bases because metal oxide itself, they are basic, opposite attracts, right? Yes, so fifth reaction I am writing. Reaction of non-metallic oxides with bases, right? Why? Because non-metallic oxides, metallic oxides are generally, there are certain exceptions here also, but we are not using general exceptional examples, generally acidic in nature. Okay, yes, so let us see some examples one by one. Reaction of non-metallic oxide with the bases, right? Yes, so here also we'll get the same thing, that is we'll get uh, the salt and water, right? General reaction I'll write down first of all. Non-metallic oxide will react with a base and it will give a salt plus water, right? Okay, so certain examples we are going to see here. So first example is for non-metallic oxide is CO2. Carbon is non-metal, therefore it is non-metallic CO2 is non-metallic oxide. CO2 reacts with a base calcium hydroxide. You remember this reaction we have already discussed. Calcium hydroxide aqueous solution. This calcium hydroxide aqueous solution is called as lime water, right? Lime water, or its chemical name is calcium hydroxide. This reaction already we have discussed in yesterday's class. So we are getting the compound CaCO3 solid plus H2O, right? Plus water liquid, right? What is CaCO3 here? CaCO3 is nothing but the limestone, or it is also called as calcium carbonate, right? It is also called as calcium carbonate. So this is the example for reaction of non-metallic oxide with bases, right? Take a screenshot of this page also. Okay, yes, now after this we are going to see some another properties of acids and bases in detail. Yes, so first of all let us talk about acids. Okay, so after these reactions we are going to discuss common properties of acids and bases. I'll start with common properties of acids first of all, right? Common properties of acids first of all. So if you observe different acids, I'll write down their structures one by one so that you will understand the point. So first of all, HCl. The structure of HCl is like this. Okay, this is nothing but the hydrochloric acid. You know the names, I'll not write them again and again. Then I'll write down the next example, and that is H2SO4. Its structure I will write down. H2SO4 is like this. Okay, this inside the bracket I'll write down because its structure is different. Okay, and this is HCl. Okay, and then third acid I'll write down for comparison. And that is HNO3. HNO3 is nothing but nitric acid. H2SO4 sulfuric acid, which I have told you already. HCl is the hydrochloric acid, right? So these are the structures of these molecules, right? Now one by one let me explain what is common in them. So if you observe, so first of all HCl, it has H in it. Sulfuric acid also has H in it, and HNO3 also has H in it, right? So if you observe, in all of them H is present, right? If you observe HCl molecule, in HCl oxygen, chlorine atom is electronegative, hydrogen atom is electropositive. Therefore chlorine will carry delta. This delta sign, this is read as delta. Delta means very small or partial charge present on chlorine. Partial negative. Delta minus sign means partial negative charge, and hydrogen will get partial positive charge. That means these electrons which are present in this bond, they are very easily shifted on chlorine, right? Because chlorine is electronegative in nature. Okay, it will attract the electrons and bond will break. After the bond is broken, what we are getting, we will get H and Cl, right? Chlorine has attracted all electrons, so chlorine will become negative, and hydrogen has lost the bond, therefore it will become positive. This H plus which is obtained here is called as a proton, right? Is called as a proton, and this Cl minus, no need to discuss about it. We are focusing on proton only. Cl minus is called as the chloride ion, right? Now this was about the HCl. Now let us talk about sulfuric acid also. In case of sulfuric acid also, you can see oxygen is there and hydrogen is there, right? Similarly here also oxygen and hydrogen is there. So what happens here also, this bond gets shifted on oxygen, right? After this we are getting the ion in which it will be HO, S double bond O, double bond O, and O minus plus H plus, right? H plus is nothing but a proton again, okay? And HSO4 minus, this also written as HSO4 minus, it is called as the hydrogen sulfate ion. No need to focus on hydrogen sulfate, our focus should be on H plus. Now again in case of HNO3 also, oxygen negative, hydrogen positive, and hence we are getting, after the reaction, H will be detached, H plus, and NO3 minus ion. NO3 minus ion is called as nitrate ion, but our focus is on proton. So in all these three reactions, if you can see, there is H plus. In all of them H plus is present. H plus is nothing but the proton, right? H plus is nothing but proton. Therefore what we can write down, what is common in them, acids donate a proton, right? Acids can donate proton, okay? Or in another word we can call as proton donors are called as acids, right? Proton donors are called as acids. So this is the first property which is common in between the acids and different acids, right? all of the acids will have this property. They can donate a proton very easily, right? So this is the first common property. Remaining properties we'll discuss in the next class. Meanwhile, you can just take a screenshot of this page and then we'll stop here for today. Okay, I hope you have taken a screenshot. Now I'll just show you the DPP. So here this is the portal on which you are first of all going to the resources, then to the writing material, then here you will be able to see the DPP on your portal. You will be able to download it, solve it on a paper and just upload it on the portal, and then I will be able to see it and review it further, right? So for today's class also you can see the DPP's daily practice problems and you are going to solve it. Okay, that's all for today, students. Thank you so much for your time and all the best to you. Thank you. Bye.